Hello, I would suggest that you pause the video and try this warm up. All right, so this is what we should have gotten. Once again, remember, I always just let X represent whatever that first percent is, and then the total minus X always represents the second percent. Okay, so we want to take each percent of the amount put in, add them together. That gives us the amount that we're hoping to earn as far as interest is concerned, and then we can answer the question from there. All right, we are going to continue with lesson 1.5, which is all about the quadratic equations. And today we're specifically going to be focusing on how we solve quadratic equations by completing the square. So, completing the square. If x squared plus bx is a binomial, then adding b divided by 2 quantity squared, which is the square of half the coefficient of x, will result in a perfect square trinomial. That is, if we were to add that on, turns it into a trinomial where then it factors nicely into x plus b over 2 quantity squared. So let's take a look at some examples. It says determine the constant that should be added to the binomial so it becomes a perfect square trinomial. Then write and factor the trinomial. So we're not actually solving in these few examples. Notice there's no equal sign. So we're just going to get a thought process down on how we do the the completing the square process. All right, so notice that the number that's in front of the non-squared term is the number that we want to focus on. So in this first example, 20 is that number. So I want to take 20, I want to divide it by 2, and I want to square it. Well, 20 divided by 2 is going to give us 10, and 10 squared is going to give us 100. So that's the first answer that they're asking for. They said to determine the constant that should be added to the binomial. So 100 is that answer. So then really, if I have x squared plus 20x plus 100, so now I've treated and turned that binomial into a trinomial. Now this is something that's factorable because now I'm looking for numbers that multiply to 100 that add to 20. And it's really going to be this number here. The number that I had before I squared it, that's going to be the number that we're going to use to create our factored answer because 10 times 10 is 100 and 10 plus 10 is 20. So because this then factors into x plus 10 times x plus 10, because it's going to factor into the exact same binomial, we then write it as x plus 10 quantity squared. And so here is my factored trinomial. In the second example, notice that the number that is attached to the non-squared term is negative 11. So to do our process, I'm going to take negative 11, I'm going to divide it by 2, and I'm going to square it. Now, in this case, negative 11 divided by 2 is not going to be a nice whole number. So I'm just going to leave my answer then in terms of a fraction. Because that whole thing's being squared, that means the numerator is getting squared and the denominator is getting squared. So negative 11 times negative 11 turns into a positive 121. And in my denominator, 2 times 2 turns that into 4. So it's not the prettiest number, but this is my constant that's going to help create this perfect square trinomial. So if we have x squared minus 11x plus 121 over 4, once again, this is going to factor, and it factors into the number that I had prior to squaring it. So that negative 11 over 2 is the number that's actually going to be a part of my factored answer. And so because it should be the exact same number, I get to write it as x minus 11 halves quantity squared. And there is my factored answer. In this last one here, notice the number that is attached to the non-squared term is negative 1/5. So going through that process, negative 1/5 is going to get divided by 2, and I'm going to square it. Okay, so this time I am going to be able to simplify what I have in parentheses a little bit, because if I'm dividing by a number, I can really think of this as negative 1/5 times that reciprocal. So it's really getting multiplied by a half, and that's being squared. And we multiply fractions straight across. So -1 times 1 is -1, and 5 times 2 is 10. So really, it's -1/10 that's being squared. So just like that second example, I'm going to have to multiply and square both the numerator and the denominator. So -1 times -1 means that 1 is going to be the numerator, and 10 times 10 is 100. So 1 over 100 is going to be that constant. And so then now if my trinomial is x squared minus 1/5 x plus 1 over 100, this is going to factor into, once again, the number that we had prior to squaring it. So we're going to have x minus 1/10 quantity squared. And this is my factored answer. Okay, so that's the process behind completing the square. So now let's get into examples of actually solving by completing the square. So notice that now I do have some equations. I've got equal signs. How I have this first problem set up, x squared plus 6x equals 7, this is actually how I want to have it. So the 7 does not get moved over. I don't want it to be in general form. I want all the x's together and then the constant by itself on the other side. So now I can just focus on that number that's in front of x like we had in all those other examples. I'm going to take 6, I'm going to divide it by 2, and I'm going to square it. Well, 6 divided by 2 is 3, and 3 squared is going to get me 9. So that's the number that gets added on to create that perfect square trinomial. But now here's the thing. Since I'm adding 9 onto the left side of the equation, I'm going to have to add it onto the right side of the equation to keep that equation balanced. But the whole point is the left-hand side is now factorable. X squared plus 6x plus 9, that's going to turn into x plus 3 quantity squared. Because remember, it's really the number prior to squaring it that ends up being inside my factored answer. 7 plus 9 on the other side is going to be 16. And now we're back to what we did yesterday, where we can solve this because this is taking the square root. Because that parenthesis quantity squared is isolated by itself, I can just take the square root to start solving for x. That gives me x plus 3 by itself. Don't forget that when you take the square root in an equation, you have two answers, so both positive and negative. And the square root of 16 is a perfect square that turns into 4. I'm going to move that 3 over by subtracting. And so we have x equals, -3 plus or minus 4. Now, here's the thing. Because those both are numbers that we can actually combine, I want us to actually combine them. So we're going to have x equals -3 plus 4, and we're going to have x equals -3 minus 4. So I do want you to finish it out. -3 plus 4 is +1, and -3 minus 4 is -7. So here are my two solutions. And once again, it's a quadratic. We should have two solutions. In the next one, x squared plus 3x minus 1 equals 0. This time it's in general form, but like I said, I don't want it in general form. If I want to complete the square, I'm going to move that constant over to the other side. And so now I have x squared plus 3x equals 1, and this is the form that I want in order to start completing the square. So we take the number that's in front of the x. I'm going to take that, I'm going to divide it by 2, I'm going to square it. Well, 3 divided by 2 isn't going to be the nicest number, so I'm just going to square each of those. 3 squared is 9, and 2 squared is 4. So that's the constant. And so x squared plus 3x plus 9/4 is going to equal 1 plus 9/4. Once again, whatever I added on to the left, I have to add it on to the right as well. The whole point is that the left side is going to be factorable. It factors into x plus, and then remember, it's the number that we had prior to squaring. So that would be 3/2 quantity squared. To help us over with the right-hand side, you can think of as 4 divided by 4, because 4 divided by 4 is 1. And so because they have the same denominator, you get to keep the denominator and now add the numerators. Well, 4 plus 9 is 13. And now we're back to, okay, well, I can start solving for x because I can take the square root of both sides. And so that leaves us with just the x plus 3 halves. Over here, we don't want to lose the fact that we have two answers. Because there's a fraction underneath the square root, we get to break it apart as the square root of 13 divided by the square root of 4. However, in the denominator, it's a perfect square. Square root of 4 is 2. And so now I want to move that 3 halves over by subtracting. And so to get the x by itself, x equals, I like to put that negative 3 halves first, then the plus or minus, and then we have the square root of 13 over 2. Now, because that second term has a radical and the first one doesn't, we're not going to combine them any further. So it's not going to be like that first example where we're going to get nice, pretty numbers. So then this is just going to be my final answer. All right, so I would suggest you pause the video, and in the first one, it's just like those first few examples where you're first just finding the constant and then factoring it. Notice there's no equal sign. And then the next one I actually want you to solve. So in the first one, hopefully we ended up with our constant being a positive 121, and then x minus 11 quantity squared is my factored answer. And then in the next one, notice that we had it in the form that we wanted to start completing the square, had to add 4 to both sides, took the square roots, had pretty numbers where I was able to get then 2 nice numbers. And that's us solving the quadratic equations this time by completing the square.